Good morning, students. My name is CH.S.V.PRASAD and I am working as senior lecturer in electrical engineering department at Government Polytechnic Yadgirigutta. Today, as we are going with the lesson AC motors, in AC motors, we are continuing with the chapter 4, that is characteristics of three-phase induction motor. In this chapter, we covered in the last class, that is the circuit diagram. We have to draw the circuit diagram from the data of no load and blocked rotor test, and how do we have to draw the performance curve. So today we will do the problem on circuit diagram, that is calculation of different parameters, that is rotor full load current, power factor, slip, rotor slip, rotor losses, efficiency, maximum torque, maximum output. So like this, all values we can calculate from these circle diagram. So before starting, we can check the formulas what we have. First one is to draw the maximum, to calculate the slip at maximum torque. So what we have to do, as we drawn the maximum torque line as shown in figure here. Maximum torque line is which one? This one. RS is the maximum, RS is the maximum torque line, and this torque line cuts the output line AB at point T, here T. So slip is equal to TS by RS. So that gives the slip at maximum torque. So TS comes in centimeters and RS also comes in centimeters. Note down this formula. And next, OP represents full load current and slip is equal to PN by, MN by PN. Note down these two formulas. So OP is the full load current. In graph sheet, see here, this OP, this represents the full load current, and slip S is equal to MN by PN. MN, here this one is there. When we draw this line, how we draw this one? First we have to add the output to this losses, that is BL, extend this BL, and from point L draw a parallel line to the output line AB, so that it cuts the circle at 2 points, that is before off and after off. So that is at U and P. We have to take the point P. From here we have to draw a vertical line, and that cuts the output line AB at M and torque line at N and AD line J and bottom line K. So if we measure this OP, that will gives the full load current, and slip is equal to Mn by Pn. M in centimeters and Pn in centimeters. And phase angle pi is equal, we can measure this V O P. This gives the angle. Or power factor cos pi is equal to Pk by OP. So efficiency is equal to Pm by Pk. So by using these formulas directly we can calculate the values. It is not required to remember any formula, just you can measure with scale. After drawing the circuit diagram we can calculate any required parameters. So any required parameters we can calculate from this one. Just measure it and get the values. So, and next, maximum output. What is the maximum output? HI. How you can draw this? How you can get this maximum output line? You have to draw a tangent. You have to draw a parallel line to the output line AB. Where is the output line? This is the output line A B. We have to draw a line parallel to this output line AB and tangent to the circle. So that is point H. From H draw a vertical line. From H draw a vertical line. So HI, if you measure HI, that gives the maximum output and maximum torque also likewise. Where is the torque line? We have AE. AE is the torque line. So we draw a line parallel to this torque line AE and tangent to circle, that is this one dotted line. So which cuts at a point R. From R draw a vertical line. So this RS represents the maximum torque. So similarly, full load torque is equal to Pn. Measure Pn, that is from here P to N, torque line N. So that will gives the full load torque, and if you require the starting torque, that is B. Where is B? B, measure this one. Root R copper loss, that is starting torque B. And next, slip at maximum torque is equal to Ts by Rs. So these formulas we have to remember, and by using these formulas, just by measuring the values we can draw the circle diagram and we can calculate the different values. So this is the problem what he given. So as I told earlier, how we can draw the circle diagram? We can draw the circle diagram from the result of, that is the data from no load test and blocked rotor test. So in this case he given the data of both blocked rotor test and no load test. What he given? He given draw a circle diagram of 20 HP, 400 volts, 50 Hz, 3-phase, star connected induction motor from the following test data, and given all values are in line values. So before doing any problem, we have to convert all values in phase values. Convert to phase value, and then we have to start the problem. So what he given? He given no load test, that is voltage reading, voltmeter 400 volts, current 9 amps, and power factor 0.2. And blocked rotor test, he given voltage as 200 volts, current as 50 amps, and power factor as 0.4. And what else he asked? He asked, find out the following values from the circle diagram. So what we have to calculate? We have to calculate line current, that is OP, and power factor, slip, and efficiency at full load. Next, BBT is maximum power output in H. So first you have to read the problem carefully and note down the given data, what he given, and what we have to calculate. So in this case, he told to draw a circle diagram of 20 HP, 400 volts, 50 Hz, 3-phase, star connected induction motor, gave the following test result. So that is no load value, that is V naught, 400 volts, and I naught, no load current, 9. Next, cos pi naught, 0.2. From this we can calculate pi naught value. So similarly, block rotor test is equal to given short circuit voltage VSC is equal to 200 volts, and ISC is equal to 50 amps, and cos phi s is equal to 0.s. So from this, pi s is equal to cos inverse of 0.4. Then you can get the angle value. So from this, calculate line current, power factor, slip, and efficiency at full load. And next, maximum power in HP. So how we can draw the circle diagram? So for this, first you have to draw x-axis and y-axis, that is voltage axis. Then you have to calculate no load current I naught and power factor pi naught. And no load current I naught is equal to vector OA at an angle of pi naught. See here, we have to draw like this. Here we have to take the from the voltage vector as a reference. So OA is equal to I naught at an angle of pi naught. So before drawing that one, what we have to do, we have to select a proper current scale and convert the I naught value and draw OA at an angle of pi naught. Then calculate current, short circuit current under normal voltage, that is ISN. What is the formula? ISN is equal to IS into V1 by Vs. So by using that we can calculate ISN, that is OB, and that one also by using the same current scale we have to convert that into centimeters and draw a vector O like this. O we have to draw pi s as a vector. Draw O. Next, what we have to do, as I told in the last class, next we have to join the points A and B. A and B we have to join like this. After joining A and B, then do bisect the line AB. Bisect the line AB. So that is dotted line. How you can bisect the line? Take a compass and radius is equal to more than off and take the A as a center point and draw two arcs here and on both sides of the line AB, more than half. Now, after drawing the two arcs, next with the same radius B as center, again draw two arcs on both sides of the line AB, so that it cuts the previous arcs, and join these two points and extend that one so that it cuts the line AD at point C. What is AD? AD is a line we have to draw from point A, which is parallel to OX. Parallel to OX, we have to draw a line starting from A. So that is now C as center and radius as AC. Draw a semicircle which passes through a point B, and we get A, B, D as a semicircle. So after drawing this, you from here from point A and point B, you draw vertical lines that is parallel to y-axis from A and B, like this. A and B. From A, that is H, from B, that is B to E, B. This B cuts the AD line at point F. At point F. Now, so this line AB is called output line, and the mark G on BF, where BF shows the rotor copper losses and stator copper losses, and H represents fixed losses, that is hysteresis and eddy current losses with a small amount of stator losses. So H is equal to Fe. This is fixed losses. So we have to get the point G like that. Vg represents rotor copper losses and Gf represents stator copper losses. So this circle diagram we will draw now. So for that one, take the no load test, that is V1 is equal to 400 volts. This is line value, and no load current I0 is equal to 9 amps, and given power factor cos pi naught is equal to 0.2. So pi naught is equal to cos inverse of 0.2. So that is 78.5 degrees. So from local rotor test, VSC is equal to 200 volts, and ISC is equal to 50 amps, and power factor cos phi s is equal to 0.4. So pi s is equal to cos inverse of 0.4, that is 66.4 degrees. So after getting this, what we have to do? We have to calculate short circuit current for normal voltage. So what is the formula? ISN. All of you note down this uh, problem. ISN is equal to ISC into V1 by VSC. So that is 50 into 400 by 200, that is 100 amps. So first you have to collect the current scale. So you have to take the current scale according to our graph. So here he taken as 1 centimeter is equal to 5 amps. So then I naught, that means we taken 1 centimeter is equal to 5 amps. So but what is the I naught current? That is 9 amps. So 9 amps convert into centimeters, that is 9 by 5. So that is 1.5 centimeters. So that is nothing but a OA. So the OA length is 1.8 centimeters, which represents the 9 amps current with a current scale of 1 centimeter is equal to 5 amps. So next, ISN is equal, we have ISN, we got 100. So 100 by 5. So that is 20 centimeters. So that is nothing but a OB. And next, we have to draw by using these two, OB and OA, at an angle pi naught and pi s. So after drawing that one, after drawing that, we have to calculate the power scale also. How we can calculate the power scale? First, we have to calculate the short circuit power. So that is root 3 VSC VSC ISC into cos phi SC. So that is called root 3 into 200 into 50 into 0.4. So that is 6928 watts. So short circuit power for normal voltage is equal to WSN is equal short circuit power into V1 by VSC whole square. So that is 6928 into 400 by 200 whole square. That is 27,713 watts. Or we can do like this also. That is root 3 into B1 ISN into cos pi SC. So that is root 3 into 400 into 100 into 0.4. We will get the same one. Note down these two formulas. This is for calculating the power scale. So we calculated short circuited normal power. After this, this power is equal to a length BG. So that is 8.1 centimeter. How you will get? Just you take a scale and in the graph measure BG. So that is 8.1 centimeter. So therefore power scale is equal to the short circuit power which you calculated at full load divided by this BG. So that is 27,713 by 8.1. That is equal to 3,421.36 watts. So full load output is equal to how much? 20 HP. So that is equal to 20 into 735.5. So that is 14,710 10 watts. Note down this full load output he given. So here what we done, we calculated the power scale. After calculating the power scale, we have to find out the total output. So from this, the length of full load output on the diagram is 14,710 by 3,421, that is 74.3 centimeters. So if we assume the stator copper losses and rotor copper losses both are equal at standstill, then you divide the point E such that BE is equal to EF. So we have to draw OA at an angle of pi naught. Then next OB at an angle of pi s. Then join the two lines A and B like this. After joining the line AB, you bisect the line AB. So just now I told how to bisect a line AB. You take the compass and take the radius as more than half. Approximately you take more than half of the radius of the line AB and take A as center and draw arcs on both sides of the line AB, on both sides from point A as a center. Now with the same radius, don't change the radius and B as center and draw another arc on both sides of the line AB, which cuts the previously drawn arcs. Now we got 2 points arc cutting on both sides of the line AB. Join these two lines as shown in with a dotted line. Now what you have to, now from point A, draw a horizontal line parallel to x-axis, parallel to OX. Parallel to OX, draw a horizontal line from point A. From point A, draw a horizontal line to OX like this, and which is nothing but a AD line. Here D point we can pick. Now extend this perpendicular bisector line so that it cuts at point C. Now C as center and AC as radius, draw a semicircle which touches the point B and got a semicircle A, B, D like this. We get a point AD. So after getting this, what we have to do? We have to draw vertical lines from point A and B. A and B. See here, A and B. From A that is H, from B that is AE, which cuts AB at point F, where H is equal to FE. So both are equal and both represents fixed losses, that is friction and windage losses and stator copper losses. So AH is equal to EF. AH is equal to EF. Now B to F. B to F represents both stator copper losses and rotor copper losses. As we told, both are equal. Take the midpoint BF as E. Pf by 2. We will get a point, and here we will get a point G, that is Bf divided into middle point G. Join A and G. This Bg represents rotor copper losses and Gf represents stator copper losses. This one is clear, everyone? Has any doubt? This is very important. The circle diagram definitely we will get for 10 marks. So this is first problem. Sometimes you will get some difficulty when you are drawing the circle diagram. But when we do 2 or 3 problems, then all your problems, doubts will be clarified. So you will get like this. So B is equal to here. Rotor copper losses, stator copper losses. This is the output line AV, torque line AE, and this is the measured torque and measured output. Here is shown E in the middle of BF, so that both are equal. Now extend GF GB further up to length L such that BL is equal to 4.3 centimeters. Just now we calculated. So from point L, draw a parallel to a parallel to the output line and intersect the circle diagram at point P. Now OP represents the full load current at this point. So like this OB, and here draw a parallel line to torque line AB that cuts at a point P. From P you join O, and P you draw vertical line PK. So likewise you have to draw both. So then what happens after drawing this one? So this one is over. So OP represents load point. From L, draw a, this I will show like this. BL, extend this GB like this. From L as a starting point, draw a line parallel to AB that intersects the circle diagram at point P. Now join OP and draw a vertical line from P, that is PK. PK. After that, OP, measure the line OP. How much he given? 6.2 centimeters. Now which scale we have to use? Either we have to use current scale or power scale. Anyone can answer? Yes, we have to take the current scale. That is 6.2 into 5. So that is 31 amps. So to find out full load power factor, we have to measure the angle V0P. So that is 31 degrees. So cos of 31 gives the power factor. Cos of 31, that is 0.87 lagging. So next, or we can use like this also. Measure PK by OP. That will gives the power factor. That is how much? That is 5.3 by 6.2. That is 0.85 lagging. So both are any formula we can use. So slip S is equal to Mn by Pn. So that is 0.3 by 4.6. So nothing is nothing but a 0.065. That is equal to 6.5 percentage. So this is the how we can get these lines. This is pi 1. So next, to calculate the efficiency is equal to output by input and into 100. So that is Pm by Pk. Pm by Pk. So that is equal to 4.3 divided by 5.3 into 100. So that is 81 percentage. Note down this formula also. 81 percentage. So next, maximum output is equal. For this one, we have to draw the output line. So that is, we have to draw a line which is parallel to the output line AB and tangent to semicircle that cuts a point at H. From H, draw a vertical line which touches AB at point I. So HI is equal to 6.4 centimeters. So that is 6.4 into 3421. Which scale we have to use here? We have to use the power scale. So then we can get 21,897 watts. So maximum output in HP. So divided by 735.5, that is 29.77 HP. So now we have calculated the full load current, full load power factor and torque and maximum output in HP. So you take the assignment as, what is the assignment? Note down. To try this problem, follow the same procedure what I explained just now and complete this. If you have any doubt, ask me in the next class. So construct the circle diagram. Note down this column. Construct the circle diagram with the given data. So what is the given data? A given a 4-pole 400 volts 30 HP 50 Hz delta connected induction motor gave the following test result. Note on this, that is no load test, that is 400 volts 20 amps and power is given 1200 watts. And next, blocked rotor test is equal to 100 volts 45 amps and 2800 watts. So what we have to calculate from this? We have to calculate maximum output and maximum torque. And next, full load efficiency and full load rotor speed. and next starting torque. So this is not a second problem, it is continuation for that one only. By mistake it taken a, here 2 is not there, it is for the same problem. Here what we have written here, draw the circle diagram from this no load and rock rotor test. From this, after drawing the circle diagram, we have to calculate the where these parameters. It's a continuation to that one only, not a second problem. So what we have to calculate? We have to calculate maximum output, maximum torque, full load efficiency, full load rotor speed, and starting torque. So in this problem also he given assume stator and rotor copper losses is to be equal. Note on this everyone, and you do this problem, and if you have any doubt you can ask me, we can discuss in the next class. So what you have to do for this one, first you have to calculate I naught, and next I naught. Next, from block rotor test, ISN, that is short circuit current corresponding to normal voltage. ISN is equal to ISC into V1 by VSC. So you can get ISN, and by taking proper current scale, you can assume that is 1 centimeter is equal to 5 amps or 1 centimeter is equal to 10 amps. You have to take the current scale such that the circle diagram must be completed within the graph sheet only, and draw OA and OB. Next join AB and calculate this. Follow the same procedure and calculate the required values. So what we learn from this, what we can find out from the circle diagram, we can find out stator copper losses, rotor copper losses, line current, power factor, slip, efficiency at full load, maximum output, full load speed, maximum torque, and starting torque. These parameters we can calculate from circle diagram. Note down this: stator copper losses, rotor copper losses, line current, power factor, slip, efficiency at full load, maximum output, full load speed, maximum torque, starting torque, rotor efficiency, motor speed. That one also we can calculate. So if you see the frequently what they are asking means draw the circle diagram and show the maximum output and torque. Or he will ask like that, list the quantities which can be determined from the circle diagram. So these two questions we can expect from this circle diagram. So you don't feel this circle diagram is very easy. You have to practice 2-3 times, then only we can able to draw in the examination. And when we are drawing the circle diagram, we can get so many doubts. If you have any doubts, ask me in the next class. We will discuss and do this problem also in class in the next class. But you have to try. On graph sheet, normal graph sheet you have to take pencil, eraser, sharpener, and a long scale, and protractor, and a compass, and a graph sheet. These things are required to draw the circle diagram and calculator. This is required so that we can draw. You follow the same steps what I explained for the assignment problem. Complete it, and if you have any doubt, we will discuss in the next class. Okay, students? Okay. Thank you.